I think we'll get started. We've got a great webinar today. Hello, everyone. My name is Marcy Marr, and many of you know me as the Kootenay Connect manager for Kootenay Conservation Program. However, I'm here today with my CMI board director hat on. And CMI, or the Columbia Mountains Institute of Applied Ecology, welcomes you today. And I'm joined today also with Kendall Benish, my colleague from Kootenay Conservation Program, or KCP. And CMI and KCP have joined forces again this year to present the 10th season of CMI's CRED Talks, the Columbia Region Ecological Discussions, and KCP's 12th Winter Webinar Series. And we'd like to acknowledge that the region in which we work is the unceded homeland of the Sinixt, Shuswap, Ktunaxa, Syilx, and Okanagan peoples, who've stewarded and cared for the land, water, and wildlife here since time immemorial. I now like to invite you to use the chat feature to introduce yourself and make your own land acknowledgement to let us know whose territory you're zooming in from today. This season of webinars explores the theme of lessons for the next chapter of restoration and stewardship. We're featuring 5 speakers who will discuss this theme from different perspectives, reflecting on key lessons from their careers in ecological restoration, land stewardship, and ecosystem monitoring, and emphasizing important insights that can and should inform future restoration efforts. This year's series is financially supported by Okanagan Nation Alliance, Tech, Ecoscape Environmental Consultants, LGL Limited, as well as KCP's program funders. To kick things off today, Dr. Stewart Rood, Professor of Biology and Environmental Science at the University of Lethbridge, will share insights from his decades of experience working in riparian and cottonwood restoration in southeastern BC, Alberta, and Montana. He'll be discussing their ecology and adaptations and describing successful restoration applications to hydro dam operations. And I'll introduce Stewart in more detail in just a moment. As introductions and acknowledgements are flowing in, I'd like to tell you a little bit about CMI. We're a nonprofit society and an association for people working in the various fields of ecology. We provide professional development opportunities in the form of conferences, courses, and webinars that address everything from field and data science research techniques to complex land management conundrums. Our website is the best place to learn more about CMI and contains great resources such as proceedings documents and talk recordings from all of our major events. And now I'd like to pass it over to Kendall Benish from KCP.
Thank you, Marcy. My name's Kendall Benish, and I'm joining you on behalf of Kootenay Conservation Program, or KCP. And we're a diverse network of close to 90 land and water conservation and stewardship groups, federal, provincial, and local governments, First Nations, land trusts, agricultural producers, and educational institutions who all contribute to conserving our region. The purpose of KCP's partnership is to cooperatively conserve the biological diversity and naturally functioning ecosystems of the region through land conservation and stewardship, and to generate the support and resources needed to advance this effort, which includes building technical knowledge and expertise through webinars like this. We're excited to be hosting this webinar series again with CMI. I would like to give an additional thanks to our program sponsors, without whom we wouldn't be able to support this type of work. Now, just a couple housekeeping details from me and we'll get started. This webinar is being recorded and will be posted within a week to both CMI's event webpage and KCP's Winter Webinar Series webpage. We'll have a Q&A with Stewart at the end of the presentation. Please use the Q&A function in your Zoom toolbar to add a question into the queue, not the chat bar. And we'll do our best to make our way through them at the end of the presentation. So you should all see that little Q&A button down there. You'll also notice in there that there's an upvote button in the Q&A after each question. If there's a question that you'd like to see answered, please use that feature. And back to you, Marcy.
Okay, thanks. So I'd like to welcome Stewart Rood as our speaker today. Following studies at the Universities of Alberta, Calgary, and Toronto, and fellowships in England and Norway, Stewart has been a professor of environmental science at the University of Lethbridge for 4 decades. His research focuses on riparian ecosystems with analyses of woodland ecology and river hydrology. He has worked with agencies across Western North America that own and operate dams to provide functional flows that balance environmental conservation and economic outcomes. Welcome, Stewart, and I'll now turn it over to you.
Thank you for that generous introduction, Marcy. I'll go ahead and start sharing if that's okay. Marcy, you've got that on your screen now?
Yes, it looks great. Thanks, Stewart.
Great. So what I'd like to do today is introduce you to a pretty cool convergence of trees and landscapes. As the title indicates, we're dealing with the trees of the people, cottonwoods around the crown of the continent. Now, I'd like to start with a pretty big scale sort of a view on things here. This is North America. In plan view, it's a giant triangle flanked by the Pacific, Arctic, and Atlantic Oceans on the three faces. But it's not really a flat triangle at all because, of course, we've got topography. So what it is a massive tetrahedron. And the apex, or the point of that, is in fact the hydrographic apex of North America. This is Triple Divide Peak, which is in Glacier National Park, Montana. It's just shortly south of the common boundary of Alberta, British Columbia, and Montana. And from this, we have streams that flow to the Pacific, Arctic, and Atlantic Oceans. This zone has been referred to as the crown of the continent. George Grinnell, who is a splendid naturalist, was so critical for the establishment of Waterton and Glacier a century ago, came up with this term. And if you drive to the landscape from the east especially, you see the splendid silhouette of the Rockies, somewhat like a massive crown. Now, relative to this crown of the continent, it's approximately oval shaped. It extends sort of from Cranbrook to Lethbridge to Missoula. The Continental Divide splits it east to west as well as north to south. And the north to south divide is, of course, pretty close to the 49th parallel. And that is why the 49th parallel was the separation between Canada and the United States. The three river systems flowing to the west, we have the Columbia, and of course, the Kootenay is a major tributary. To the northeast, we have the Oldman that flows into the Saskatchewan and ultimately Hudson Bay. To the southeast, we have the tributaries of the Missouri River. When it's in flood, it's the Misery River, and it flows into the Mississippi and Gulf of Mexico. Let's call it the Gulf of Mexico still. Relative to these landscapes, these river systems were really central to activities by humans as well as all other animals as well. If we think about the settlement, not only by the Europeans, but long before that, by the indigenous nations, the movement was up and down along these rivers, and most of the cities and towns are established along rivers. And the reason is the rivers provide us with the resources we need, such as here in Cottonwood, Idaho, and the sign helps us out. The explorers could have seen a sign like this, perhaps. We've got fuel wood for heating and cooking, centers of activity for fish and wildlife, for food, timber for building materials, and the most widely used pharmaceutical globally is aspirin, salicylic acid, which you get pretty high doses from if you gnaw on the inside bark of willow or cottonwood. So if you're out in the bush and your friend busts a leg, strip some of this off and it'll reduce inflammation and pain. These trees are referred to as cottonwoods because of the conspicuous cottonwood fluff. These are specialized hairs around the seeds, and what they allow these to do is to float in the air or in the water. And sometimes we think about the release of these in early summer as summer snowfall. This particular tree is ripe and ready for a gust of wind to disperse these thousands of seeds. Relative to the naming, these are the trees of the people. And so the genus is populus, which is people. And the basis for this is the Europeans, like the North Americans, involved the development or the settlement of most of the towns and cities along rivers. And they were not in the canyon zones, but instead the broader valleys and those alluvial floodplains were ideal for settlements. We have a painting by Claude Monet, Le Peuplier, there, and that's actually the French or European black poplar. The Roman Empire planted Lombardy poplars along the thoroughfares to recognize their landscapes or their ownerships. Now, relative to the poplars, there are two general categories. Aspens, which I'm sure most of you are very familiar with, are the upland trees. And as shown in this splendid autumn photo, what we have is clones or clusters of individuals linked by a common root system. And so they share resources. You can see this with the cluster of orange trees. Those are all together actually one individual with multiple trunks. And then we have the yellow cluster and the green, etc. So these are the trees of the people. Relative to the values of the cottonwood forests or the ecosystem services of these forests, cottonwoods provide the foundation for a woodland community. And so they support and allow for the occupation by other plants, both in terms of the trees and shrubs and understory layers. And these provide the richest habitats for birds and other wildlife in our regions. The trees have extensive root systems which stabilize the banks, reducing erosion, altering sedimentation, and in fact, having a major influence on channel form and channel dynamics. The cottonwoods and willows contribute dramatically to the aquatic ecosystem. In fact, the food web is largely dependent on the leaf and branch litter from these. So this really provides much of the carbon that provides the basis for that. And they also provide shade and shelter. Cottonwoods are really good at utilizing water and removing nitrogen and phosphorus, nutrients, as well as contaminants. And interestingly, they're very good at absorbing pharmaceuticals in water, which is quite difficult for our water treatment plants to remove. They're also centers of activity for us. So if we think about our parks and protected areas, a lot of them are in the river valley zones with cottonwoods. We like them for wildlife, for viewing, for bird watching, aesthetics, the list goes on. They also provide shelter in our favorite locations during rough weather for livestock grazing. But of course, we have the challenge there of riparian management, balancing things such as livestock grazing and reproduction of these trees. A few photographs of some of the plants or animals you'll see. We've got a pair of bald eagles right across from our place every winter. They're right across from our house right now along the Elk River. Porcupines are great. They spend the winter often up in the trees, gnawing on the bark. Occasionally they fall off, which is actually a substantial cause of mortality of porcupines. And beavers, of course. You might not know that there's another mammal that climbs up the trees. And it turns out that, in fact, the nutrients provided by the developing seed pods are really rich. A splendid study by Wilson et al. In Alaska indicated that, in fact, for the fast-growing phase of young black bears, these somewhat sort of like grape clusters of developing seeds are very nutritious. Here we have 5 young black bears up in a black cottonwood tree near Fernie. It's a splendid photograph, and if you go on the web, if you look at YouTube and stuff, there are a few videos having these black bears climbing up branches, and of course they tip over, and occasionally the trees break, and the things come tumbling down. They always run away, so hopefully they don't get hurt. But it's quite interesting and something you might not think of. But if you spend enough time looking at cottonwoods, you will see this. These are the 5 different primary poplar species of North America. In the upper right, I'd mentioned the trembling or quaking aspen, and this might be the most widespread tree on our continent. The other 4 are the cottonwoods. So these are the riparian trees, starting from the left. That darker leaf is the black cottonwood, Populus trichocarpa. I've got its distribution in blue, so it occurs in the Pacific Northwest, extending down to California. And it occurs in landscapes that are somewhat wetter. To the north, in pink, we have the balsam poplar, which is very closely related, very similar in form and function. It occurs in the boreal region right across Canada, quite widespread in our country. To the east and especially southeast, we have the plains or prairie cottonwood, Populus deltoides. Its leaf is in the lower right and it's somewhat triangular, hence the name deltoides. And finally, a tree that is less common, less understood, the narrow-leaf cottonwood, Populus angustifolia, is literally narrow leaf. It's commonly mistaken for a willow. And willows and cottonwoods are the two different genera for the Salicaceae family, and so they're somewhat related. And this poplar or this cottonwood is kind of an intermediate between cottonwoods and willow, at least relative to the functionality. Now, what's interesting is these four cottonwood species originate from the four ordinal directions, moving up and down the river systems, converging again in the crown of the continent. So it's a really interesting area. And so we think about a center for activities of animals, but also of plants. This is a really rich and diverse woodland. This is Cottonwood Park, just south of Lethbridge. In the distance, we have Glacier and Waterton. From Glacier, we have the St. Mary River that flows in our picture to the left, and the larger Oldman from Waterton to the right. And this is where they're converging to Fort Whoop-Up, which now is Lethbridge. This woodland has at least 3 and possibly 4 of the cottonwoods that we have in this region. So it may be the most diverse poplar forest anywhere. But in fact, it's even more diverse than the 4 species because they interbreed, they hybridize. We can recognize the hybrids by intermediate forms. And so if we look at the parental leaf shapes, the hybrids are pretty much exactly in between. Now, when we think about hybrid poplars, we might think about these fast-growing trees. Hybrid poplars are the fastest growing trees in temperate regions around the northern hemisphere, very popular for wood production, fiber, and fuel, North America as well as Europe and Asia. And I've got a picture there from our collections in the University of Toronto Faculty of Forestry years ago. And that leaf of a hybrid from a French and American hybridization, these leaves are the size of dinner plates. And you can look at the growth rate of this cross section. It's just extremely fast-growing trees. Another view on the bottom, we have a sequence of lines from Riney Statler, University of Washington. On the left, we have the hybrids. These are from the deltoides and black cottonwood, and on the right we just have the black cottonwood types. And you can see the difference, even though the environment is the same, the dramatic differences in growth rate. We refer to this as hybrid vigor or heterosis, but it's not all good. We also have something called hybrid breakdown, and it's certainly the case, and in fact, it's commonly the case, that the broader the genetic range is for these hybrids, the more vulnerable they are to pests and disease. We refer to this as hybrid breakdown, and in this particular branch, we have these bud mite galls. They're somewhat like cancerous tumors. And so hybrid poplars grow really fast, but they are also prone to these sorts of things. They've been referred to as the James Dean of the tree world, live fast and die young. Now, when I came back to southern Alberta and the Crown of the Continent region after spending a bit of time, okay, in Toronto, it was nice to come home. What I started to do was collecting natural intersectional hybrids. And as I did this, what I found is that there was an enormous variation in the condition of the riparian cotton woodlands along different river systems. This is the St. Mary River again. It drains Glacier Park, Montana. This particular area includes hybrids of the narrowleaf and black cottonwoods, quite nice, really nice paddle. This is just north of the border from Montana into Alberta. There is a dam downstream from this, and below the dam, we have a view that's in the lower photograph. This is called Box Canyon. It's a really pretty little canyon, a really nice paddle, but the cottonwoods have collapsed. And in the upper right, I show you a plot of the abundance of the cottonwoods over a half century from 1950 to 2000, where you can see the dramatic decline. And the reason for this is drought stress. And so the water was removed. This is the largest irrigation complex in Canada. And so from the reservoir, the water is removed for irrigation agriculture. But we were interested in these trees and particularly the survivors. So we went out and studied them and clonally propagated them. And lo and behold, there was a surprise because the survivors are predominantly male. So like us, members of the willows and poplars are dioecious. They're separate individuals that are male and female. And it turns out that females are more vulnerable to drought stress. This is a concern if we dewater a stream relative to the use for irrigation or with climate change, which is also increasing aridity. And the problem is if we lose the females, we lose the seed source for the next generation. As we undertook these studies, it wasn't all bleak, and we came up with an idea. And the idea was the impact of dams on cottonwoods is not solely or primarily based on whether or not you have the dam, but instead how the dam is operated. And as we studied a few different dams and operations, we came up with a concept called ramping. And the point here is that high flows happen. After the high flows, naturally there's a gradual recession as the system dries out. In contrast, with a dammed river, often the operators want to cut back the flow as quickly as possible to reduce that challenge or hazard. Now, we'd suggested that is a problem, and you've already had the flood crest, and so you've already had the biggest flow. You're not going to have any more flows. And so what we'd suggested is that operators should try to mimic the natural recession through this gradual recession. We built some model devices to find out what the rates should be, and it turns out that the seedling roots of cottonwoods can elongate at about an inch a day. 2.5 centimeters a day. So that became our target relative to the recession rate. 1955 was the flow of record for the old man through Lethbridge, and it was convenient. We'd already had some studies that were released. The mayors of Lethbridge and Medicine Hat suggested to the premier, look, the group at U of L think that if you ramp, there might be some benefit. Let's give it a try. We were pleased that the premier and minister said, yep, go ahead. And so the three major dams, and one of them is the Old Man River Dam, quite controversial. There it is in the picture, as well as the Waterton and St. Mary. And these were ramped to mimic the natural recession of an inch a day, and did it work? There were thousands upon thousands upon thousands of new cottonwoods along hundreds of kilometers of river valley following this. Was really quite extraordinary to think about this. And to some extent, what we've done then is basically mimic the natural pattern. Now, we've done this on other systems as well, and the plot for the Waterton River, which is another nice one to work on. And so in this particular plot, a high flow year is less impact proportionally than a low flow year. And so the blue line is the natural. The red line was what our target was. The green line was what we delivered and the success we start to see. And it's a kind of a nice picture in the lower one. We get to see our kids who are now full size, as the cottonwoods are as well. Coming into the Kootenay region, I can tell you another story that's a good news story, and it's an interesting one. And so the Kootenay River has a major dam on it, the Libby Dam. This is near Libby, Montana. And so this is about an hour south of Fernie. It creates a reservoir, Lake Ktunaxa Reservoir. And this dam was completed in 1972, and it was allowed by the Columbia River Treaty. The Columbia River Treaty required the construction of 3 dams in Canada, Mica, Keenleyside, and Duncan, and it permitted the construction, or rather the completion, of the Libby Dam project in Montana. This dam is actually owned and operated by the U.S. Army Corps, so it's not bound by the terms of the treaty as the Canadian treaty dams are. The Canadian treaty dams especially are operated with a very narrow range of objectives, and particularly flood risk management, primarily for the American cities downstream, but also hydropower generation. Now, related to that function, you can think about Mica Dam and the massive Kinbasket Reservoir that extends between Golden and Valemont. It's huge, and it holds a lot of water, and that water is being released right now. It goes through turbines at Mica Dam and then downstream through Revelstoke Dam. used to go through turbines. It might still at Kingsley side. I'm not sure if they're functioning presently, but it then goes through about a dozen dams in the United States that also have turbines. And so by storing water in the headwater in Canada, basically what you've got is a massive battery storing potential power that can be released when it's needed in midsummer. So from the engineering point of view, from the economic point of view, this made sense. Unfortunately, the economic impact was devastation. And so in this photograph, I've got Ktunaxa Reservoir. The upper picture is how it often looks in July and August, which is kind of fortunate timing because that's when people want to recreate on the reservoir, and it's somewhat lake-like. Ktunaxa is very popular, warm, clear water. It's pretty large. It's about 160 kilometers, about half in Montana, the other half in BC. It's about midway between Cranbrook and Fernie. But through the winter, it's drawn down for these two functions. One is to release water for power generation, but at the same time, what it also does is draw down the reservoir, providing vacant capacity to absorb the flood peak. The result is this lower view is in April. It's tragic. It's a landscape that is, if we had something called ecocide, this is pretty much what it would be. And one can imagine that prior to the flooding of this, prior to the clearing of this, this would have been extraordinary relative to the black cottonwood forests. This is a broad valley in the Rocky Mountain Trench. They're braided channels. It would have been just quite something. I've seen aerial photographs and some ground level photographs, but I'm sure that they really don't give me a full appreciation of the richness that we lost with that flooding. The Columbia River Treaty was enacted with a 60-year time frame, which recently expired. And so there was consideration to renegotiate and modernize the treaty. And both the Americans and Canadians, and certainly the other related groups, and especially the indigenous nations and the American tribal nations, are in somewhat agreement that maybe we can do a bit more. Rather than this narrow, too objective, let's add a third leg to the stool, ecosystem function. And this is not just for the natural ecosystem, but it's also for the human element as well, related to socioeconomic sorts of aspects, indigenous culture values, etc. So if we think about what happened with respect to Libby, it provides a case study that to some extent is promising and might be applicable to some extent for the other three treaty dams. In the upper graph, what I have in blue is the natural hydrograph. Low flow in the winter, increasing with the spring melt, increasing steeply as the melt accelerates and also spring rains, peaking in June, and then gradual recession through July and August, and lowering back to the next winter. Now, this particular hydrograph is an average of a couple of decades, and so no individual year is quite that smooth, but it's a pretty predictable function that we call a naval regime or a snowmelt dominated hydrograph. For the first 2 decades after Libby was in place, the operations were like red. It was deliberately operated to completely attenuate the spring peak, and it's a whopping big reservoir relative to the Kootenay and Elk rivers that flow into it. And thus it's capable of absorbing the whole peak. The water is released in the winter for power generation, and so to some extent you invert the hydrograph. High in the winter, low in the summer. This caused problems for the natural organisms that occupy the riverine ecosystem. One in particular was the Kootenay River white sturgeon. This is endemic. It's separated from the other white sturgeon in the Columbia system by Bonington Falls between Nelson and Castlegar, which were impassable. And so this fish then evolved separately or diverged and became a separate genetic population and strain. The only place it occurs is in the Kootenay system, occupying Kootenay Lake and spawning in Kootenay River, primarily between Creston and Bonners Ferry. Following the implementation of Libby Dam, reproduction ceased. It already had been dramatically reduced due to overharvesting, habitat impacts, pollution, lots of other things as well. But the final impact was Libby Dam. And if the impact is partly operation, maybe then operation could change to provide some benefit. The white sturgeon, the Kootenai River white sturgeon, was listed as endangered. The American Endangered Species Act is really powerful. It specifies that all federal agencies that are relevant have to do something. U.S. Army Corps had to do something. So what they started to do was to release a pulse for sturgeon spawning. And this is shown in the lower hydrograph, but keep in mind the scaling of these in the y-axis is off a twofold different. And so a peak pulse was released, but it was still only a fraction of what the natural peak would have been. The original sturgeon flows were in purple, and subsequently it's a more normalized regime in green. With the original purple sturgeon flows, something unexpected happened, and that is that there was a flush of colonization of cottonwood seedlings. This was accidental, or we're referring to as collateral. So you provide a normalized flow regime for fish that are endangered, and you actually partly rejuvenate riparian population dynamics, which is pretty cool if you think about it. Kind of think of this as black and white flows for black cottonwood and white sturgeon. And so this is interesting. And following the success, the accidental success, we've now been gradually implementing, especially ramping again. And again, that's the green flow. And so you see the layers there with the collateral, accidental, and then the deliberate. So we're now at a point where we can pretty predictably reestablish cottonwoods along the segment of the Kootenai River between Bonners Ferry and Creston that doesn't have cattle grazing and or other localized impacts. So it's kind of a good news story. But wait a minute, something else. Lo and behold, the cottonwoods that are there, the newly established juveniles, they're not black cottonwood. They're the plains or prairie cottonwood, Populus deltoides. Now, this cottonwood has been progressively moved westward by the settlers. It was planted in the Bonners Ferry area by 1900. But additionally, the seeds are blowing over in the wind. Even though the winds are prevailing from the west, there's also ones that go back the other way as well. And so it's quite interesting that the vast majority of these newly established juvenile cottonwoods are plains cottonwood, Populus deltoides. That's pretty interesting. Now, we should think about this relative to our philosophy of restoration and conservation. We used to think about what we really want to do with restoration is turn the clock back. We want it to go back to the way it was. For most river systems, that's no longer an option. You can't go back. So instead, the consideration is, well, what can we do with what we have today? And one thing in this particular case is that we now have a new riparian woodland. Instead of the prior native, we have a new one, but I think it provides the same functionalities relative to ecosystem services. And so I think it's probably a pretty good thing. And even if it was a bad thing, there's nothing we can do. It's way past that point. So it's pretty interesting to think about this relative to the philosophy of restoration. We can't turn the clock back. So that gives you a glimpse of the sorts of things that we've been doing. A couple of papers I'll refer you to. This upper left-hand one is a review paper that talks about this strategy of managing river flows, ecological flows or ecosystem flows. And basically what we've contributed to this dialogue is an emphasis on high flow years. Because if we can fortify the riverine ecosystems in wet years when there's enough water to go around, hopefully we improve resilience for the inevitable dry years. Relative to the Kootenai story and Libby Dam, we also have this paper in the lower left, and it's kind of an interesting description of how that happened. I've got to acknowledge the various agencies that have been so helpful to fund us, Alberta government, BC government, Ktunaxa Nation, as well as Kootenai Tribe of Idaho, NSERC, et cetera. And I certainly want to recognize the many excellent students who have come. And in fact, I've had more grad students from BC than Alberta in our program. And it's just been really, really rewarding seeing their success. I have great sense of pride as I go to meetings these days and I see our former students. Plus, they're already indoctrinated. And so, in fact, they're thinking about these sorts of things. So that then gives you a taste of trees of the people, cottonwoods, and the crown of the continent. Thank you.
Oh, thank you so much, Stewart. That's totally fascinating. Love to learn more about one of my favorite trees and everything that you've just stitched together in this storytelling. So, yeah, and the James Dean and hybrids is James Dean. That's a take home, hey?
Yeah.
So there are a few questions here. And let me see. So I'll just go through them, Stuart, and we'll just see how we do in the next 15 minutes or so. The first one here is when you mimicked the natural river fluctuation resulting in thousands of cottonwood regen, did many of these trees persist?
Um, uh, yes, there are still lots and lots, and we've probably gone from millions to hundreds of thousands. So proportionally speaking, the majority die. But if you think about it, in those densities that you see, you end up with in the order of hundreds of seedlings per square meter in our inventories. Whereas the size of a tree is big. And so if you only have one per 100 square meters, 10 by 10, you're probably still doing pretty well relative to closing the canopy. So excellent question. And yes, indeed, the majority of tree seedlings die naturally, and the majority of them also died with our environmental flow regime. I think that the survival rate would be higher with our progressive deliberate, gradual ramping. Because, if you think about the thing, and we can actually use the dams as a tool um, to
Mm,
provide a more gradual recession than would naturally occur. And I might suggest that as we're losing our snowpacks and things like that, we might need to think more about what we can do with our dams and storage reservoirs relative to environmental enhancement. Anyway, back to the question. Yes, most of them died, but there's still lots. There's still this massive legacy of woodland that followed from each of these flow experiments.
great. Okay, here's another one. Could the turnover from black cottonwood to deltoides have something to do with differences in water stress tolerance moderated by changes to average sediment size that result from sediment capture by dams?
Wow. Wow, what a great question. Okay. So, yes, indeed, the sediment regime has dramatically altered, but to some extent, what you have downstream from a dam is coarsening because the the material settles in, all the sand settled in, and so you end up with clear water that's being released, and so that's hungry water, which then has a greater capacity. So, in fact, zones downstream from dams tend to be coarser. But the other thing about it, with respect to in that question or comment, there was a thing about changing over time. It's likely, I think, that the different conditions today might be more favorable for deltoides. It's partly related to the sediment regime and profile, but I think it might also be related to climate change. And so if we think about warming temperature, increasing aridity, those are conditions that probably favor deltoides. And so it might well be the case that in this situation, climate change is actually driving this element in a way that some might regard. We don't want to call it positive, but it's something that for that particular plant, it's enhancing it. Great question.
Great. And here's a related one, maybe. Do cottonwood need exposed mineral soil to germinate? And how can recruitment be restored in regulated rivers that attenuate the scour that generates exposed soil where development has now encroached into the floodplains, like the Nechaco River?
Oh, another great question. What a wonderful audience we've got. So yes, indeed. So the cottonwood seeds are tiny. They're just these tiny little things, about a millimeter to 2 millimeters in diameter. And so they don't have a lot of stored reserves, and so they are not competitive. Cottonwood seedlings do not compete with established vegetation. So there must be a barren site, preferably mineral. Okay, and so sands are ideal. And so, yes, if there is a attenuated flow regime that allows for encroachment of upland or transitional vegetation into the sand and gravel bars, you will not have cottonwood establishment. And so part of the requirement of cottonwoods for floods is, in fact, the physical geomorphic disturbance that creates these new barren colonization sites. Relative to a stabilized system, one can provide some physical excavation to actually provide this. On the Truckee River in Nevada, we did this. We actually went in with an excavator to provide barren sites, and it worked, sort of. Um, it's stopgap sort of a thing, but it's a possible thing. But yes, indeed, if you have encroachment, you exclude cottonwood colonization.
Okay. And this person is wondering if you could speak to recruitment and survival of cottonwoods in unregulated rivers like the Upper Duncan versus downstream regulated systems.
Okay. So Duncan's a great story. Um, so the Upper Duncan is pretty cold, pretty cool, somewhat interesting. I'm more familiar with the Duncan that was flooded by Duncan Reservoir. It used to be Duncan Lake, and of course, the zone upstream from that would have been a splendid wetland zone that would have been extraordinary. But what's interesting about the Duncan is that downstream from Duncan Dam, the operators, BC Hydro, actually implemented an environmental flow regime. And the intent was to enhance cottonwood recruitment. We followed that up. Mary Louise Polson was really the one who led this, and it was a pretty interesting study. What we found is that that system was already in pretty good shape, and the reason for it is that the Lardo is free flowing and joins immediately below Duncan Dam. And so the Lardo contributes to the sedimentation and dynamics that's essential. And so in that particular case, you have a recovery of the geomorphic processes and the ecological processes by the inflow of a substantial tributary. The question is a bit more about the Upper Duncan. If they're thinking upstream from Duncan Reservoir, I guess I'm less familiar. I've been up there, but not a lot. But the Lower Duncan, below Duncan Reservoir, is a pretty interesting case study.
Okay. And here gets to your conversation around ramping. Did you find that ramping was most important in a particular season for cottonwood propagation?
Okay, so that's something I hadn't mentioned, and probably I should. So these cottonwood seeds are only released in a very limited um, interval. And so generally, the cottonwoods, the maturation, so we have pollination and then maturation, ripening. Again, we've got these grape lake clusters that the black bears are eating anyway. And so they release the seed typically in early to mid-June. And that is the time when naturally you have your post-peak recession. So there has been this natural convergence of the or coordination of the timing. So cottonwood seed release naturally occurs after the standard time of the peak. Now, it turns out that there's something that goes on maybe a little unusual in the Kootenai system, and it's really kind of cool. And in fact, it was discovered by Brenda Herbison on the Duncan. And that is that cottonwood seed release is promoted by a rain event. And so if you have a rain, it's the warming right after the rain that leads to the final ripening and release of the seeds, which again is ideal because then they're going to land on a wet site. So anyway, naturally the cottonwood seed dispersal period is very limited. They're tiny seeds, and so they only have a few weeks of viability. Okay, so if you think about cottonwood seeds, it's exactly the opposite of coconuts. Okay, they're tiny and they don't last very long.
Awesome. Thanks. Um, so here's a question I've been wondering too. Do you think cottonwood riparian zones are at risk? And if so, beyond changes in dam flows, what would you suggest are important ways we can restore cottonwoods along rivers and streams, either direct or indirect actions?
So, relative to impacts on riparian woodlands and cottonwoods included, we have direct clearing, okay, and so we clear zones for pastures and crop fields and towns and roadways and like so. The direct clearing, we need to think about this, okay, and so if we have areas that are healthy and intact with natural woodlands, we should think twice about harvesting them or clearing them, okay. But the other thing is in Western North America, dams and water withdrawal is probably the second largest impact. The largest impact is livestock grazing. And so cattle especially, and sheep as well, but especially cattle, they're much more abundant. Um, they browse, okay. A lot of the ungulates love cottonwoods, okay. And if you have a cottonwood that goes down in a park, then the elk come storming towards it and stuff. It's like candy for them. But anyway, so cattle grazing is a problem, and it turns out not only to be browsing, but the trampling is a big deal, and something called pugging, which is the perforation of the sediments, especially on that wet stream bank, eh? And what we've been to sites with extensive colonization. We go in there, we're measuring, we come back the next day, and it's zero because the cows have been let in. And as they are pugging through that surface, all of the seedlings are uprooted and die. So the biggest single impact is livestock. And in Alberta, there's a splendid program called Cows and Fish. It actually is a spin-off from another splendid program in Montana, Paul Hansen's program down there. And basically what it tries to do is develop grazing management strategies, not strategies that exclude livestock, but instead strategies that manage livestock. And so it's rest rotation, off-stream watering, X, Y, and Z. So I would say your biggest single target would be livestock management. And then number two is, I would say, dam operation, and we're working on that. And again, the other thing is the direct clearing for the various uses that we have.
Yeah. And so getting back to the first part of that question, is this an ecosystem that's at risk and one that should be top of mind for our area?
Yeah, so Bob Jameson did some really, really good stuff. And what he was dealing with is mapping cottonwood zones. And there's actually a relatively limited number of really healthy, intact woodlands. One is the Lardo. I think the Lardo is splendid, okay? The elk is in pretty good shape. I mean, the elk right now is facing all the problems related to the coal mining and pollutants and stuff like that. And also, it's really popular. And there's a lot of Albertans that are sort of developing properties along the elk and stuff like that. So what I think we want to do is to think about what's left. And yes, indeed, as a broader ecosystem type, because of the pressures on rivers and riparian zones, cottonwoods are indeed under threat. There is an element that relates to this too, and it's both the United States and Canada, but especially the United States. The conservation initiatives in the United States are so focused on threatened and endangered. Cottonwoods are not. There's a lot of them still, okay? But as an ecosystem, we have this problem of the ecosystem being threatened. And so the mechanism for conservation, if it's based solely or primarily on individual endangered species, we have a problem because we'll be neglecting ecosystems. And so it's the broader cottonwood ecosystem that I think is threatened.
Okay. Here's a question on behalf of our friendly Lewis's woodpeckers, who are wondering if there's any hope for cottonwoods in the Okanagan. If the water managers are able to make any changes to their water management regime to promote the reestablishment of cottonwoods where they have been lost.
I saw that Casey Moran had signed in, okay, and she's the person that's the pro on this. Um,
Okay.
what I will say is that the Okanagan is kind of like the old man in that these are semi-arid regions in which drought stress is a big problem. Relative to the old man, you need to establish the population. And for a lot of birds, okay, it's the old trees with all the branch and crown dieback and the cavities and stuff that those are so critical. They're really ragged. They look kind of ratty, but they're fabulous wildlife habitat and they're fabulous and essential for some birds. So for the Okanagan, it's a tough one, but gosh, there's a lot of good stuff going on, and we're all so excited about the recovery of anadromous salmon in the Okanagan. Let's work a bit more on the riparian zone as well. I wouldn't give up on it, but it's going to take some effort.
Okay. Here's another one involving one of our favorite critters. So it sounds like cottonwood and beaver, our natural or ecosystem engineer friends, have an intimate relationship. Can you speak to that
Oh,
for us?
absolutely. It's a real love-hate thing for me, let me tell you. So we have a property. I'm not now on a property. It's along the Elk River, just south of Fernie, and we have a whack of beavers here. But we've got a whole bunch of cottonwoods, and so it's not a big deal. The problem is balance. And on the lower St. Mary, we changed the flow regime. We ended up with a sequence of groves of cottonwoods. Beavers went in and mowed them right down. And it was really unfortunate. And so what you really need to do is think about balance. Beavers are great in moderation. Okay. If you have a threatened riparian woodland, you don't want beavers. That's one more element that will be a problem. And so beavers are really good relative to groundwater systems and wetlands and things like that. There's a lot of positives, but at the same time, if you have a declining riparian woodland, beaver control is an element that you might think about.
Yeah. Okay, here's another one, shifting gears a little bit. In developed areas, scouring may not be an option, but plants could be. Can you? But planting could be. Can you comment on the success rate of propagating and planting juveniles?
Yeah, it's really good. It's really easy to propagate cottonwoods. So cottonwoods, you simply take stem cuttings and you simply, put them in moist. And in fact, generally speaking, for riparian restorations, what you'll often do is you simply insert live stakes. And so you'll take cuttings when they're dormant. So it might be March, April. And you go to the field and you might use a stinger, which is called a high pressure washer device. And what it does is excavate a little hole, or else you can use a rebar or bite, and you jam the live stake in there, and some of them will survive. In a hot, dry year, very few do. In a cooler, wetter year, many do. Okay, so riparian restoration through plantings is very successful, but one has to be patient. One has to understand that it works some years well, not so well other years. Lots and lots of cases of successful plantings. And I think it's done, as the question involved, for a zone such as a developed area. However, from Arizona, which had maybe a longer history of riparian restoration, the conclusion about planting is if you have a water regime that is lethal for cottonwoods, it will be lethal for planted cottonwoods, so don't bother. Conversely, if you can restore the water regime, you'll end up with extensive volunteer propagation and establishment that will overwhelm your planting. So don't bother. And so what that means is that you need to pay attention to what the causes of the mortality are in an area where it's development. And so you have a problem such as a city. Okay. In those cases, plantings are great. Okay. For park plantings and stuff like that. Conversely, for a broader area, such as the Lower St. Mary, planting is a little more challenging because you really first need to fix the water regime.
Okay, related to that, fixing water regimes and thinking about water levels. Someone's interested in knowing more about the success of cottonwood propagation on the perimeters of large reservoirs like Arrow Lake.
Great question. Okay, so and I'm not sure what I can say. And the reason is that I've been working with Kathy Eichenberger and the others as part of the treaty team. And Arrow Lakes Reservoir is, of course, an element that's been challenging and controversial, et cetera. So what I will say is that if we think about Arrow Lakes Reservoir, there a couple of years ago, they were a really tough year. And part of the problem was the abrupt rate of recession, leaving boats literally high and dry. And that will also leave cottonwood juveniles high and dry. And so the concept of gradual recession of a reservoir should be equally applicable as it is to a reservoir. We have a concept for the treaty ecosystem restorations. We call it FRW, floodplain, riparian, and wetland. I'm not sure if Craig Itzig might be online, but he's really the guru on this. But what it is seeking to do is to deliver water regimes for reservoirs such as Arrow that will indeed allow for the establishment and survival of cottonwoods, of willows, of dogwood, and the list goes on. I think it's possible, but what it takes, there's a cost, and the cost is water. And so if we think about the business of managing for flood risk management, and especially for hydropower, there will be some trade-off, some balance relative to the ecosystem function as opposed to the economic objective. I think the Arrow is a system that's interesting and somewhat promising, but also somewhat challenging.
Yeah, yeah. So there's a I don't know, maybe 7 or 8 questions, but I think we'll just take 1 to 2 to respect your time, Stewart. You've talked a lot, and this has been really informative. Plus, let everybody get on with their day and end at 1 like we usually try to do. So, I think there's been a couple of things in your talk that have, talked about drought and various stress factors, and just wondering your thoughts on, how climate change is affecting cottonwoods from your perspective.
Yes, climate change is affecting everything, and for sure, anything related to rivers is a big deal. I think, and we've done some studies on this, I think that what we might expect along a number of river systems, both free-flowing and regulated, is a narrowing of the riparian woodlands, the extent. So I'm hopeful that we'll still have that diversity, but the aerial extent might be declining as a result of the generally increasing aridity with climate change. We, of course, have problems with flow seasonality. We're losing snowpacks. May have flashier systems. We may have more intense weather events. The list goes on. All of these are going to be influential. All of these need to be factored in relative to our management. It's a big deal. It's an important deal. I'm hopeful, as I say, that we'll still have riparian woodlands, but I predict that in a number of river systems, they will be narrower.
Okay. And this relates to one question I was wondering about in terms of your James Dean analogy for hybrids. So are hybrids potentially a winner with climate change, or is there any relationship between what you showed us in terms of the hybridization?
I think hybrids are really um, related to silviculture, and so the
Okay.
hybrid poplars are great for the production of biomass. If you want to produce wood for a toilet paper, a newsprint, or whatever it might be, it makes no sense to be harvesting old growth. Okay, and so what you can do is you can grow plantation type of hybrid poplars. This is done in a big scale in the Columbia Valley of Oregon, so east of Portland, on the Washington side as well, but especially the Oregon side. And again, so if you want to produce fiber, if you want to produce biomass, hybrid poplars are great. I don't think hybrid poplars will help us in native riparian woodlands. Um,
Okay.
and yeah, I think that may be a general pattern.
Okay. Well, I want to thank you very much. I know there are still some remaining questions, but we will send you Stuart's contact information and other resources or papers that he may have that he wants to share with everybody. And yeah, we just want to thank all of our supporters and sponsors again for this webinar series and having such great folks like Stewart join us. And so thank you again, Stewart, and everyone who's tuned in today. And we look forward to seeing you again in 1 week on next January or next Thursday, January 29th. We've got Audrey Amen, who's going to be talking about management and restoration of brushlands and other dry ecosystems in the West Kootenay. So we're going from far one corner in the southeast over to the southwest of our Kootenay, Columbia Basin area. And we hope to see you next week. Have a great rest of the day. Bye, everyone.